Okay, thank you. So I'm starting today's meetup with how to catch all the rendering regressions on the Bevy engine on all platforms. So the question is how to test a game engine on macOS, Linux, Windows, iOS, Android, WebGPU, WebGL2, and all that in continuous integration. A quick word about who I am for those who don't know me. I'm Mokersf on GitHub. I'm using and contributing to Bevy since the 0.2 version, so that was some time ago now. And I'm a maintainer and SME on several topics on the Bevy engine. If you have any idea how to improve the testing, don't hesitate and come talk to me. So how do we test a game engine? Of course, it's code, so we can have unit tests. Their goal is to test a specific function. In Bevy, the coverage is very low in unit tests. We are pushing more and more for adding them in PRs, so it's increasing. But at the same time, aiming for 100% coverage is not a good thing. It would just slow us down. Another kind of test we have in Rust is the doc test. They are the documentation test, and they are here to show how to use a function. But it's not made to test the engine, it's made to test the user experience of the engine, and they typically, for example, don't have any assertion. Another kind of test in Rust we have are the integration tests. They are here to test the public API and to test how different modules work together. And we have a few in Bevy. We can look at the test folder and notice that they are not actually tests for Bevy, but they are here to document how to test your game. So yeah, Bevy doesn't have an integration test at all. And the last kind of test we have in Rust are the bench tests. They can check the performance of a function, and it's easy to compare them between runs. Most of the bench tests we have are focused on the ECS. We also have a few on reflection and on async task, but yeah, it's mostly ECS. And the last part of Bevy for the test are the example. They are a big focus of Bevy because they are an easy way to demonstrate how to use the feature and to serve as a demo for the engine. We run a few examples in CI to catch crashes. So when an example crash, it will fail the CI job and we will have to monitor. For example, we had a long time issue with reducing the window size to 0 pixel that was crashing everything. So we have an example in CI that will just change the window size to 0 and test that everything still works fine. And more, we are encouraging contributors to run the example related to PRs to check that they are working. Okay, but what about rendering? How do we test rendering in CI? Are we going to write unit test or integration test and maybe check that the rendering world has everything as expected, or that we are generating the correct command? Those kind of tests would be very hard to write, very hard to maintain, and very brittle. So maybe not the best idea. So I want to speak about visual test. The idea is to do snapshot testing. We take a screenshot before the change, we take a screenshot after, and we just compare them. For comparison, there are a lot of algorithms available. I mentioned a few here, but the main one I'm using for the moment is pixel by pixel because it's just the fastest and the simplest. I think I'm going to try using Flip from NVIDIA, mostly because it's quite cool how it works, but yeah, not yet. And the good thing is we can reuse the example. So the idea is to run every example in the Bevy repository, take a screenshot, and then compare the screenshot with the last execution on main. And the tool I'm using and yeah, of course, in Bevy, we have a feature for that. It's a feature Bevy CI testing that is introducing an easy setup that will make us have a constant frame rate and that is able to send event at given frame. For example, with this file, at the frame 200, we'll get a screenshot. At the frame 900, we will exit. The use for that was to make all the example determinist. So to be able to compare the screenshot, I need the example to render exactly the same at a given frame. So every example is using a fixed time step. And when you need something random to happen in the example, we are using seeded random so that it always happens the same. And the tool used for screenshot comparison is Pixel Eagle. It's an image comparison as a service. It was made with Bevy in mind by myself. And to be very fast and reduce cost, it first do an hash comparison of screenshots, and it will be pixel by pixel only when the hash are different. It's very basic for now and still evolving. Another thing that could be interesting are bench tests for the renderer. We do have some example for bench test, the stress test, but yeah, for the moment, it's not possible to use them in CI. It's blocked on having actual hardware. But we could start by already writing the documentation and having everyone agree on how to run them to test the renderer. But okay, so we know how to test rendering, but really on all platforms, we have a few constraints. We need them to be in the cloud, headless, and reliable. So let's see with the GitHub runners. The first one is Linux. Okay, it's possible using LLVM pipe as a software renderer, XVFB to get a virtual X11 desktop. And this is the system info and the adapter info we get on this. So yeah, it's working. It's not the fastest. It doesn't have all the features and bell and whistle, but it's working. And we need to do something similar for Wayland. I started to look into it. It seems to be possible, but yeah, I don't have a lot of experience with Wayland. macOS, lucky for us, it just works on the new M1 GitHub runners. They were public maybe a few months ago, but yeah, they are very fast and they are working with a software renderer too. Windows, it used to just work, but yeah, it's degrading more and more. And it started with every example loading a GLTF file failing, and now just most 3D examples don't work. So I just disabled them since a few days ago because it was just giving way too much error. Windows is probably the less valuable platform in CI because we already have a lot of contributors using Windows, so we're trusting people to test them on their local machine. For Wasm and WebGL2, I tested many configurations in CI with different host OS and different browsers, and it works very, very well in CI with Ubuntu, with Firefox, again with the XVFB and LLVM pipe. For the moment, the scope in CI is very limited. It only runs 6 examples, and it's using a browser script with Playwright, that is a browser automation tool, and taking a screenshot, same, but this time it's not yet with a built-in feature to take a screenshot from Bevy, it's using the one from Playwright. Wasm and WebGL2, WebGPU, same thing. I tried all the configuration and I found that macOS and Chromium works in CI, so it mostly works like WebGL2. iOS, we are running tests on 3 versions of iPhones with 3 versions of iOS. And it's thanks to Browser Stack open source support, we are able to use the real physical devices. What we are doing is running the mobile example and driving the test with Appium, which is a mobile software testing tool. And again, we are not using the built-in screenshot from Bevy, we are using the feature from Appium, but I'm not sure it's possible to use the feature from Bevy this time because it will save the screenshot locally on the mobile device and then it will be hard to get it back. Android, same as iOS, thanks to Browser Stack, we can run on real devices. We are testing on 4 devices, but to note, the first one, the Xiaomi Redmi Note 11, it's broken at the moment because GPU preprocessing is not working on it. And yeah, with Android come a lot more limitations. Some GPU don't support MSAA, some GPUs don't support shadows. It's a bit of a pain with the various GPUs and what they support. So how does it look? I will switch to my browser now to show you. So this is my repository when I run all the actions. I don't run them on the Bevy repository because it would take a long time and it would block pretty much every other action because as you can see, it's running a lot of jobs in parallel. This is all the job for native on Linux, then on macOS. This is all the various mobile devices. And this is the two run on a WebGPU and WebGL2. So yeah, that's a lot of job running. And every run is taking 7 hours. When there was Windows, it was a lot longer. It was taking 14 hours to run everything. Once all the examples are sent, the screenshots are sent to my tool, Pixel Eagle, that allows us to compare screenshots. For example, if I take the latest run on Linux, I can see differences. Yeah, this example, it has a lot of differences, and I can compare screenshots between the last and the previous version. So yeah, a few shapes were added, so the example is different. As we can see, some examples have a lot of differences. It's because there are very, very tiny bit of difference. This is the auto exposure example, and yeah, it doesn't exactly render the same always. Same for the SSIO example. There are a few pixel difference on the edge and transmissions also. For this kind of examples, pixel by pixel comparison is not the best, and I will need to use maybe flip. That should work better. And then the last tool is the example report. It's a static site deployed on GitHub pages that will list all the run and let me see the differences and where it crashes. So yeah, this is a new example. It didn't run before. This one did change, so we can see the different shape. As I was saying, on the Xiaomi, it's failing, and we can see everything like that. So auto exposure is almost every time changing on Linux, never on macOS. So that's one of the reasons I didn't investigate it a lot, because I'm on macOS. By default, it's only showing the examples with some changes. If we click on that, we have all the examples, and that's a lot of them. And most of them are stable and working very well. So yeah, a few screenshots of the tools for people just looking at the slide. And what are the next steps? Not that everything is working like that. I want to be able to add more mobile devices, but I'm waiting for some bug that will soon hopefully be fixed. At least they are in the milestone for the next version. The linked here is a page of Browser Stack with all the devices they offer. The goal is to have a good coverage of various GPUs, OS version, and device manufacturer, mostly for Android. I also want to improve the WASM test because they are not yet in the report page. It's quite recent that I added them, and for the moment they only run 6 tests. I want to be able to run a lot of them. And yeah, I want to be able to take the screenshots through Bevy to not have the screenshot from the browser, but to be able to test rendering from Bevy. For error reporting, when an example crash in native, it's easy to get the log because I just have to read the GitHub job log. But on WASM or mobile, it's a lot harder. On WASM, it would be the browser console. On mobile, I would have to check the various logs of the mobile devices with ADB or the equivalent for Xcode. It's not easy. So I'm trying to hook up Sentry to get all the logs, all the error log in them. It's working fine, but on pause for the moment because as Windows was crashing a lot recently, I exploded the free quota on Sentry, so I'm blocked for the month to continue investigating on that. Another thing I want to add with the Bevy CI testing feature is to be able to send a command for keyboard or mouse input. For the moment, I have two commands. I have a screenshot and app exit. So I want to be able to simulate a keyboard or mouse to be able to change things or interact with the example. For example, in the anti-aliasing example, we can change the mode by pressing some keys during the run. So I would like to be able to press the key, then take a screenshot for each different mode. It would also allow me to be able to test different scenes on mobile because we have only one example. So the goal would be to have different pipelines and maybe a 3D scene, a 2D scene, something with different light to be able to test all that in mobile. More features that I want to add to the BVCI testing feature is a command to print diagnostic because when it's crashing in CI, it's not always easy to find why. So yeah, being able to print debug values would be very useful. And the next, and it would be pretty much allow us to do anything, it would be to have a command to run a one-shot system. We could have a one-shot system that would check anything on entities, on components, and crash if not valid. That way it would be picked up by CI. Or we could trigger complex change and change the scene, change the state, change everything in what's being rendered to test it. And that's nice, but yeah, it's only running every 6 hours and only if there is a commit in merge in a main. My goal would be to be able to run maybe a subset of all the example on each PR validation, and it would comment on the PR with the result. It would not block because, yes, sometimes change in the example are expected. There is a PR open for stat. It's not yet reviewed completely. It's not yet working as expected, but it's the first step. And as soon as it's merged, I will be able to continue. And finally, I want to improve Pixel Eagle. It's already nice, it's already working, but yeah, there are a few things I could improve. A better listing page of all the run, more comparison than just pixel by pixel, because for some example, it's not enough. I would like to be able to declare in your zone in a screenshot, for example, for mobile when there is a time displayed. I want to not get the difference of the time. And I would like also to have more users than just Bevy to help finance the servers that at the moment I'm paying by myself, and to have more feedback and develop the tool into something more useful. So how can you help? For some of the next step, for example, the new commands with BVCI testing, we just need someone to do it. So yeah, come and open PRs. If we want to be able to run more tests, it would cost more money, obviously. So sponsor the Bevy Foundation. And yeah, if you think visual tests with Persegal would be useful for you, for your project or your company, come talk to me. Some closing thoughts. We are very near the end of what's possible for free. Running all the example is slow. When I wrote the slide, there were 241 examples. There are two more already since then. So yeah, it's always increasing. We have always more. It's going to be slower and slower. If we want to be able to run faster, we need bigger runner, more runners, and that's going to cost money. If we want to enable Windows again, we would need bigger runners. So yeah, again, more money. And some point in the future, it would be nice to be able to test against realistic configuration, not just software renderer. And again, it would cost money to have actual hardware. Some very basic calculation. So for the current workflow, it's taking all the minutes I just wrote, and it would cost $13 per run if I was using private runners. Luckily, I'm on the free tier yet, so I'm paying nothing. If you wanted to add that to the repo, to the Bevy main repo and run on every PRs, it would cost around $2,000 per month just for the CI. And it would be even worse if we had Windows back and use faster runner. I, I did a simulation, it would be around 4,000 or 5,000 dollars. And if we want to use hardware collocated in a data center, we need obviously to buy the hardware, but then collocation in the data center is around $150 per month. But the big cost would be to have an admin available, because we would need someone to be on call. So that would cost a lot of money. And again, it's just everything that I just presented is not just for the game engine. It's everything is set built in Bevy, and you can use it to test your game. Don't hesitate to test all your targets in CI. You test your shaders, test everything in the UI, test your transition, test your games. Thank you.
Wow. That's a lot of money that we would need. Thank you, François. Super insightful, and it's amazing to have this kind of test happening. Even I'm not even sure a lot of people were aware that this is running in the background. Since when is that the case?
I started with simpler version a long time ago, maybe 1 year ago, but yeah, I'm always adding things to it.
Oh, wow. Okay. So we have a few questions in the Q&A platform. I'm going to just pick the first two, and then we save the rest for later so that we can give the other guys the stage. The first question, pretty straightforward. Can the foundation get funding by AWS or similar cloud providers, I guess, to run all of that stuff in their device farm?
We could, but I think to get from a big corporation like that, we need the official non-profit organization, which we are still waiting for.
Oh, I thought this is all done now. Okay.
No, we did the paperwork, but we're waiting for the IRS feedback.
Gotcha. Okay. Well, that would be a promising way to handle this problem, right?
But yeah, we're already lucky because we're funded by BrowserStack to test on real mobile devices.
Yeah, that's already amazing to have. And the second most voted question is, do you have an example of a bug that we caught using this system?
For rendering bugs, Yeah, there was a few. Well, to be fair, check the most of my peers because most of the time now they're just to fix bugs. Very recently there was not a bug, but yeah, we did a change in exposure on emissive materials. So the lava, for example, was looking a lot brighter. So yeah, that's something that I fixed.
Mm.
But yeah, for time to time, we are losing the UI, or we are losing some part of rendering, or some shaders don't work anymore.
And as a side question following up on that, how much work is this in terms of maintenance that goes to there's actually something that got broken versus this is a false alarm, or this is an intended change that is following a PR that someone did?
Not that I removed Windows, not a lot.
Quite some Windows bashing here. Okay. Cool. Yeah, I would say we save the rest for a panel conversation at the end. Thank you, François, so much. I think everyone in the community is super grateful for your work in there, and especially it shows in the quality of the releases that we see that this is getting more stable and stable with every release. So, François, thank you so much for your
Thank
presentation.
you, and enjoy the rest of the meetup.